In this video, we'll be talking about vectors of unit length or unit vectors. A vector of unit length or a unit vector is simply a vector that has a magnitude of 1. So we have new notation here. We've got this vector here, which is, again, the bracket 1 comma 0. So this is a unit vector, and we label it as I. I know that's going to be confusing because I is generally denoted as the imaginary number, the square root of -1. But when we talk about vectors, I is the unit vector in the x direction, while j is the unit vector in the y direction. So in that case, I can write vectors using i's and j's instead of these bracket notations. So to clarify this, I'm going to go ahead and do this part first, where it says let's write this vector right here in terms of i's and j's. Well, if I is specifically the vector 1 comma 0 and j is specifically the vector 0 comma 1, then if I want to go ahead and write this vector as simply i's and j's, it's the same thing as saying, well, I have -4 of the I vectors, because if I multiply I times the -4, that becomes -4 times the 1 here and -4 times 0, which doesn't change. Plus my j, but I'm going to need 2 of those, so 2j. So this is really the same thing as this vector here, and it's just a different form of notation. Now, it's important to understand that you shouldn't intermingle these two notations. Don't put i's and j's inside of these angled brackets. Make sure that either you're using this notation or you're using unit vector notation. Now, it's important to also understand that what we're doing here is different than finding the unit vector in this direction. So a unit vector in this direction is specifically a vector of length 1 in the direction of the exact same vector that this goes. Now, for this one, I'm going to go ahead and draw this image so that it might be better to understand. So you're going -4 comma 2, so 1, 2, 3, 4, and then up to 1, 2. So the terminal point of that vector is sitting there. The starting point is generally at the origin, so I want this vector to simply be condensed down to a vector of length 1. So I want it to be the vector that sits on this unit circle, so I want the vector to be there. I want to know, more or less, what is the vector v in that same direction, such that the length is simply this little portion right here. So the goal to finding that is, well, we're first going to have to find the magnitude of this vector. So let's go ahead and find the magnitude of what v is. The magnitude of v is going to be, again, the square root of the x coordinate squared plus the y coordinate squared, in which case I'm going to have the square root of 16 plus 4, which is simply the square root of 20. If we want to simplify this, we can break that down to be 2 square roots of 5. So that's the magnitude of this particular vector. Now, the secondary question, and again, the main question is what is the unit vector in the direction of this vector? Well, to get the direction constant, but the magnitude simplified or smaller, how about let's just take the length of what that vector is, and let's divide the original vector by its magnitude. Again, by dividing a vector by its magnitude, we don't change its direction. Again, by changing its direction, we have to manipulate the coordinates or negate the overall vector. So what we're going to do to account for this is simply take each coordinate piece inside that vector, so -4 comma 2. We're going to take each piece of that, and we're going to divide it by 2 radical 5. So in this case, my actual vector of unit length in the same direction as v is going to be -4 divided by 2 square roots of 5, comma 2 divided by 2 square roots of 5. Now, again, it's important to note that we should probably continue to use the constant notation that we have already here. It's also important to note that we don't like radicals in the denominator, so we're going to have to rationalize that denominator as well as simplify. So the first step is simplifying -2 over the square root of 5, comma 1 over the square root of 5, and if I want to rationalize that denominator to simplify this in its entirety, I would end up with a -2 square roots of 5 over 5 with comma radical 5 over 5. And this, again, should have vector brackets. This is the vector of unit length in the direction of this vector, while this is the vector written in terms of i's and j's, written in terms of unit vectors. So again, what's a unit vector in that direction versus what is the vector written in terms of unit vector notation. So that's the concept for how we deal with unit vectors. And again, this little detail is something you're going to want to make sure that you have clearly understood in terms of manipulating and how to deal with identifying a vector of unit length in the direction of another vector.